So today we're just going to review a little bit of our algebra. We're going to need that for the upcoming lessons in geometry. And the first three examples that we're going to take a look at, we are just going to work on simplifying each expression. And I want to point out to you that the word simplify and the word solve mean two different things. When I simplify my expression, you notice that these are not equations because they do not have an equal sign. So we're simply going to take a look and see if we can combine like terms. And if I take a look at number 1, I can see, well, I have a 4x here and a 3x, and we know that those are like terms. We could combine them. 4x plus 3x, we would have 7x. I have a y over here, but I cannot combine an x and a y. They are not like terms, so I'm going to have to leave that separate, and I also have a minus 2. So 7x plus y minus 2 is as simple as I can make that expression, and that would be my final answer. If I take a look at number 2, I have 7 times the quantity x plus 3 plus 2, and I can see here with my parentheses, and I need to go ahead and distribute my 7. Once I distribute, I'm going to end up with 7x plus 21, because we know when we distribute, we're multiplying. I still have my plus 2 here. And now when I take a look at my like terms, I see, well, I can take a plus 21 and a plus 2 and add them together. So I end up with a 7x plus 23 as my final answer. The last one, for number 3, it's asking us to simplify if I have the quantity y plus 3 times the quantity y plus 4. And if you remember from algebra, there's a couple different methods or different strategies that you can use when you simplify this or when you multiply it. And one of them is called the FOIL method, and the other one is called the box method. And you might have a preference one way or the other. I don't care which way that you do it. I'm going to show you both ways. I'm first going to show you the FOIL method, and remember that the letters F-O-I-L stand for first, outside, inside, last. Really what we're doing is we're just taking and we're distributing. We're going to distribute our y first, and then we're going to distribute our 3. So when I FOIL, I take my first terms and I multiply them. Well, that's going to be y times 1. And hopefully you remember that y times y is going to give me y squared. My outside terms is y and 4. Well, y times 4 is going to give me 4y. Now I'm going to look at my inside terms, and my inside terms are these two right here, 3 into y. When I multiply that, I get 3y. My last terms, last one in each group, is going to be the 3 and 4. Well, 3 times 4 is 12. Then you want to check to see if you can simplify, if there are like terms you can combine, and in this case there are, because I can take a 4y and a 3y and I can add them together. Now, can I add my y squared with those? No, I can't. A y squared and a y are two different types of terms. I can't combine those. My final answer is going to look like y squared plus 7y plus 12. And that is as simple as I can make that. Now, just to refresh your memory, if your algebra teacher taught you to use the box method looks like so, where you take your term, y plus 3, I'm going to put that in vertical, and y plus 4, as so. And the boxes, the intersection is what you get when you multiply the terms together. So y and y, this is going to give me y squared. And a y and a 4 is going to give me 4y. A 3 and a y, and a 3 and a 4. And then you want to just see if you have like terms. And of course, we should get the same answer as we did above, and we still end up with y squared plus 7y plus 12. So you can do those either way, but those are the two strategies that you would use when solving those. If we take a look at the bottom three examples, 4, 5, and 6, I am asking you to do some solving on these. And when we solve our equation, we are looking to find one final answer. What is our variable? If I take a look at number 4 and I have 3x plus 10 equal to 22, I know that I want to work to get x by itself. I want to isolate x. So the first thing that I'm going to do is I'm going to get rid of this plus 10. Well, the opposite of adding 10 is subtracting 10, right? What you do to one side of the equation, you have to do to the other. And so I'm going to set it up. I'm going to keep things lined up. My 3x is going to stay the same. Plus 10 and minus 10, well, we know that that's going to equal 0. 22 minus 10, or 22 plus a negative 10, well, that's going to give me 12. So now, with a little bit of rearranging, I have 3x equal to 12. I'm still wanting to get x by itself. So 3 times x, we're going to divide. And this would leave me with x equal 4. X equal to 4, we know we can check that answer by plugging it back in and making sure that 3 times 4 plus 10 does in fact equal 22. And it does. If I take a look at number 5, it's similar. I have negative 2x minus 4 equal to 14. Our two-step equation here. The first thing that we're going to want to do is we're going to want to take a look at this minus 4. The opposite of subtracting 4, we're going to add 4 to both sides of my equation. Sometimes the teacher will tell you, they'll have you put a vertical line here by your equal sign to help you keep things lined up. Let me do that as well. I have negative 2x minus 4 plus 4. It's going to give me a 0, and that's going to be equal to an 18. Negative 2 times x equal to 18. Well, I'm going to have to go ahead and divide by a negative 2, which is going to leave me with a final answer of x equaling negative 9. And again, we could plug that back in to make sure that we come out at positive 14. The very last one we're going to look at is number 6. You'll see number 6 looks just a little bit different because I have x term on both sides of my equation. And so what we're going to want to do is we want to get our x's on one side and our numbers on the other. A lot of times what I do is I start by moving my smallest x term. And so if this is a positive 2x, and I want to look to get it to the other side, I'm going to go ahead and subtract 2x. Now I'm going to subtract 2x from both sides of my equation, again here being kind of my divider. And so 2x minus 2x is going to cancel to a 0, or equal to 0. I have a negative 15 equals, well, 5x minus 2x, or plus negative 2x, is going to give me 3x, and then I'm going to have my plus 15. Now sometimes kids will look at this and they'll say, oh, that's 0. Minus 15 plus 15. Well, when we're doing our rearranging, I'm looking to get my numbers on the other side. I'm actually going to subtract 15 from both sides. And we'll see that we actually end up with a negative 30 equal to 3x. Negative 30 equals 3x. We want x by itself. We divide both sides by 3. We find that negative 10 is equal to x. We can switch that around and say x is equal to negative 10. So those are your 6 review questions on simplifying expressions and